Members, welcome to this discussion. Again, we are looking at how we can use the mid-ordinate rule with 7 ordinates to estimate that integral. So the guiding question says use the mid-ordinate rule with the 7 ordinates to estimate integral of 1 out of 1 plus x from 0 to 3 with respect to x, and we corrected this answer to 3 decimal places. Right away, let's start. Okay, so we have to understand the mid-ordinate rule. So in the mid-ordinate rule, we are using the midpoints of each subinterval. Okay, the midpoints of each subinterval substituted in the value, I mean in the function f of x, then determining the value of the function f of x, which is y. Then later on, we will use the formula h, okay, into y naught plus y1 plus y2 plus dash dash up to yn minus 1, and this shall give us the value of this integral. H is the width of each subinterval, and h is equal to b minus a out of n, whereby n is the number of subintervals, and it is always going to be the number of ordinates minus 1. So the b and a are the upper and lower limits respectively for this function that we have been given. So this is going to be a 3 minus 0 divided by n. N here is going to be 6. So the number of ordinates, we are saying we have 7 ordinates, okay? And this is equal to 6 subintervals. So 6 subintervals, so meaning we are going to divide it by 6 here. This is going to be 0.5. So now that means we are talking about starting from 0, okay? We are going to go to 0.5, we go to 1.0, 1.5, 2.0, then we go to 2.5, we go to 3.0. And now the points that we are going to use are going to be the midpoints of each subinterval. The subintervals are meaning 0 to 0.5, 0.5 to 1.0, 1.0 to 1.5, and so on and so forth. So the midpoint here is the one that we are going to use. And this is going to give you the value of y0. This is going to give you the value of y1. This is going to give you y3 up to the end. So y4 up to y5. Okay? So what are we going to do? We are going to look at 0.5 plus 0 divided by 2, and we'll have 0.25. So that's what we shall start with, 0.25. So at a space of 0.5, we will be going to 0.75, 1.25, 1.75, 2.25, 2.75, okay? And that's the end, because we are saying 2.5 plus 3.0 divided by 2, we will find that we are having 2.75. So this one is not there. Now, that means we are going to be substituting each of these values into this function. So if I substitute in those values, 0.25 at the place of x, I'm going to have 1, okay? This is going to be 1 divided by 1 plus 0.25, and this is going to give me 0.8. So if I substitute in 0.75, it is giving me 0.57, 0.5714. Then if I substitute in 1.25, my calculator, it is giving me 0.4444. Then if I put in 1.75, it is giving me 0.3636. If I put in the 2.25, it is giving me 0.3077. If I put in the 2.75, I'm getting 0.2667. Okay, So from there, I will have done the much of the part that is required. So that means, okay, this was the integral of f of x with respect to x approximately to that. So the integral from 0 to 3 of 1 out of 1 plus x with respect to x is approximately equal to our h is 0.5 into what is our y naught. Our y naught is here, this is y naught, this is y1, this is y2, up to y5. So this is going to be y naught plus y1 plus y2 plus y3 plus y4 plus y5. So if I put in those values, this is going to be 0.5 into 0.8 plus 0.5714 plus 0.44444 plus 0.3636 plus 0.3077 plus 0.2667. And this is approximately equal to 1.377, and this is the 3 decimal places, which is the required level or degree of accuracy. So this is the approximate integral of 1 out of 1 plus x, limits 0 to 3 with respect to x. Thank you.